Bismillahirrahmanirrahim. Today, the topic of my presentation is non-parametric test, one sample sign test with assumptions and weakness under kind supervision of my professor, Dr. Sarah Afzal. Learning outlines. What is non-parametric test? When to run non-parametric test, assumptions, limitations, sign test, one sample sign test with assumptions and example, and recent updates and MCQs in the end. Learning outcomes. By the end of this presentation, participants would be able to describe the assumptions and weaknesses of non-parametric test along with hypothesis testing using one sample sign test. Now, what is non-parametric test? It is a method commonly used in statistics to test and analyze ordinal or nominal data with small sample sizes. Unlike parametric tests, non-parametric tests do not require the researcher to make any assumptions about the distribution of the population and so are sometimes referred to as distribution-free method. Typically, this method will be used when the data has an unknown distribution, is non-normal, or has a small sample size that the central limit theorem can't be applied to assume the distribution. Now, when to use non-parametric test? In experiments when the data is not normal, sample size is so small, all the tests involving the ranking of data are non-parametric. Non-parametric statistics are also known as distribution-free statistics. It may be applicable when the nature of the distributions are unknown. We are not willing to accept the assumptions necessary for the application of the usual statistical procedures. Some people believe that any kind of data, no matter what the distribution, can be correctly analyzed using non-parametric methods. Many believe that most non-parametric methods require that the distributions be continuous, symmetrical, and independent. Data that are categorical or attribute measurements, these are known as nominal observations. That is, the observation is given a name. Thus, a person is observed to be a male or a female or black, white, or yellow. Sophisticated level of measurement involves data that can be ranked in order of magnitude. Kind of ordered data are known as ordinal measurements. Continuous variables are ordinal measurements. Now, usage in decision making, forecasting, studying populations that take on a ranked order, such as a movie reviews receiving 1 to 4 stars, simple analysis. Now, types. First is chi-square test. It is used to compare between observed and expected data. It is a test of goodness of fit, test of independence, test of homogeneity. Kruskal-Wallis test for testing whether samples originate from the same distribution, used for comparing more than two samples that are independent or not related. It is an alternative to ANOVA. Then third is Wilcoxon sign rank test. It is used when comparing two related samples or repeated measurements on a single sample to assess whether their population mean ranks differ. Median test. It is used to test the null hypothesis that the medians of the population from which two samples are drawn are identical. The data in sample is assigned to two groups, one consisting of data whose values are higher than the median value in the two groups combined, and the other consisting of data whose values are at the median or below. Then comes sign test. It can be used to test the hypothesis that there is no difference in medians between the two continuous distributions of two random variables x and y. Fisher's exact test. This is a test used in the analysis of contingency where sample sizes are small. Now, these are the different situations, and here we will discuss where a parametric test is used and non-parametric test used. If the data type is ratio interval, then we use parametric test, and if it is ordinal or nominal, then non-parametric test is used. The usual central measure is mean while using parametric test, and it is median while using non-parametric test. Correlation test, Pearson while using parametric test, and Spearman for non-parametric test. Independent measure, two groups. Independent measure t-test and Mann-Whitney test in non-parametric test. Independent measure more than two groups. One-way independent measure ANOVA. Kruskal-Wallis test is alternative in non-parametric test. Repeated measure two conditions, match pair t-test while Wilcoxon test in non-parametric test. Repeated measure more than two conditions. In parametric test, we use one-way repeated measure, that is ANOVA, and Friedman test while using non-parametric test. Now, limitations of non-parametric test. cannot easily use confidence intervals or effect sizes, have less statistical power than parametric tests. Nominal and ordinal data provide less information, and it is more likely to commit type 2 error. Now, coming on to our main topic, sign test. It is a non-parametric test that is used to test whether or not two groups are equally sized. The sign test is used when dependent samples are ordered in pairs where the bivariate random variables are mutually independent. It is based on the direction of the plus and minus sign of the observation and not on their numerical magnitude. It is also called the binomial sign test with p-value 0.5. The sign test is considered a weaker test because it tests the pair value below or above the median and it does not measure the pair difference. Now, the main question answered is that which product is preferred, for example, which product of soda, either Pepsi or Coke, is preferred among a group of 10 consumers. Now, assumptions made while applying sign test about data distribution is that the sign test is a non-parametric, yeah, means that it is distribution free test. So we do not assume that the data is normally distributed. Two sample data should be from two samples. The population may differ from the two samples. Dependent sample should be paired sample or matched, also known as before after sample. Now, types of sign test. One sample in which we set up the hypothesis so that plus and minus signs are the values of random variables having equal size. Paired sample. This test is also called an alternative to the paired t-test. It uses the plus and minus signs in paired sample test or in before-after study. In this study, null hypothesis is set up so that the sign of plus and minus are of equal size or the population medians are equal to the sample median. Now, we use sign test for the following, like to determine the preference for one product over the other, to conduct a test for the median of a single population, that is we do in one sample sign test, or to perform a test for the median of pair difference using the data from two dependent samples. Now, the one sample sign non-parametric hypothesis test was used to test the null hypothesis that the median of a distribution is equal to some hypothesized value k. The test is based on the direction of the data are recorded as plus and minus signs rather than numerical magnitude. Hence, it is called sign test. One sample sign test. The one sample sign test simply computes a significance test of a hypothesized median value for a single data set. The one sample sign test is a non-parametric hypothesis test used to determine whether statistically significant difference exists between the median of a non-normally distributed continuous data set and a standard. This test basically concerns the median of a continuous population. The one sample sign test is to compare the total number of observations less than or greater than hypothesized value. The one sample sign test is a non-parametric version of one sample t-test. Similar to one sample t-test, the sign test for a population median can be one tail, that is either right or left tail, or two tail distribution based on the hypothesis. The sign test for a population median can be one-tailed or two-tailed distribution based on the hypothesis. In left-tailed test, the claim about null hypothesis that the median is greater than or equal to hypothesized value k, while in alternative hypothesis median is less than the hypothesized median, and the vice versa in right-tailed test. In two-tailed test, the null hypothesis states that median is equal to hypothesized median, that is k, and in alternative hypothesis, median is not equal to hypothesized median or value k. Assumptions of the one sample sign test. These are data is non-normally distributed, a random sample of independent measurements for a population with unknown median. The variable of interest is continuous. One sample test handles non-symmetric data set, that means skewed either to the right or to the left. Procedure to execute one sample sign non-parametric hypothesis test. First is state the claim of the test and determine the null hypothesis and alternative hypothesis. Second is determine the level of significance. Third is assign positive and negative signs to the sample data and determine the sample size. And n is usually the sum of positive and negative signs. Fourth is find the critical value. Fifth is compute the test statistic. And the main thing to remember is that if the sample size is less than or equal to 25, then we use y. And y is the smaller number of positive and negative signs. And for this larger sample size, that is, if it is greater than 25, then we use this formula. 6 is make a decision. The null hypothesis will be rejected if the test statistic is less than or equal to the critical value. 7 is interpret the decision in the context of the original claim. Now, here is the example in which we will use the one sample sign test. A branch manager of a bank indicates that the median number of savings account customers per day is 64. A clerk from the same branch claims that it was more than 64. Clerk collected the number of saving account customers per day data for 10 random days. Can we reject the branch manager's claim at 0.05 significance level? So this is the data for 10 days in which the daily savings per day is given. Now, null hypothesis states that the saving account customer median is equal to 64. However, the alternative hypothesis is that the saving account customer median is greater than 64. So, we would assign observations less than 64 with negative sign and observations above 64 with positive sign. So this is the data of 10 days which is given. Now the values which are greater than the median 64, they would be assigned positive values like 66, 65, 70, 68. So as these all values are above 64, so we would assign them the positive value. Now the values which are less than 64, they would be assigned negative sign like 60, 46. So total number of positive values is 8 and total number of negative values is 2. As we have seen that we have the data of for 10 days. So out of 10 days, 8 values were of positive sign and 2 were of negative sign. Now test statistic is minimum of these positive or negative values, that is 2. Test value taken is the smaller number of plus or minus signs. So here we had two negative values. So it is the minimum of 8 and 2. So test value will be 2. Now we would look at the binomial table. The corresponding value for 8 is 10 and for 2 is 0.5, and 10 is the number of trials and 0.5 is the 50% chance that more than the median value and 50% chance less than the median value, and the significance level is 0.05. Now we can see that these 10 values, out of these 10 values, the first two values 0, 1, they show the rejection region, and this from 2 to 10 this shows the acceptance region. Since this test value 2, it falls in the acceptance region, so here the other thing is that the corresponding p value is 0.05 with the corresponding 2. Now we can see that the probability for x to is equals to 2 is 0.055, as we have seen from the binomial distribution table, and it is greater than 0.05. Since test statistic 2 is in the acceptance region, hence we would fail to reject the null hypothesis. So there is no significant evidence that the savings account customers per day are more than 64, because here we are accepting the null hypothesis, we are failed to reject. So our proof is that the saving account customers per day are not more than 64. Moving on to recent updates. This is an article titled as Parametric Test for Non-Normally Distributed Continuous Data for and Against. Choosing between parametric and non-parametric statistical tests for analysis of non-normally distributed continuous data is a long-standing controversy. Conventionally, it is recommended to use non-parametric tests, but few others suggest using parametric tests. This article evaluates the simulation studies comparing the parametric test with non-parametric tests and analyzing the non-normally distributed continuous data. Non-parametric tests are recommended only when data is highly skewed and long transformation technique cannot change it to normal distribution. However, in most other situations, parametric tests are more useful in analyzing non-normally distributed continuous data. Here is the conclusion. That even though non-parametric tests are independent of normality assumption, they depend on equal size and variance of the two distributions. So non-parametric tests should only be considered for the continuous data when the distribution is highly skewed and long transformation cannot change it to normal distribution, and when normality of these data cannot be assumed from reports of these data elsewhere. Oh, MCQs. MCQ number one. Sign test is the simplest non-parametric test that determines a preference for one product over the other. What population parameter can be tested with the sign test? Mean, median, standard deviation, variance, error.
B.
Yes, B is the right answer. MCQ number two. The sign test is a non-parametric test that is used to whether or not two groups are equally sized. Which of the following is not true about the hypothesis? The null hypothesis for the scientist that the difference between medians is zero. The null hypothesis for the scientist is that the difference between means is zero. The alternative hypothesis that the difference between means is not equal. The alternative hypothesis that the difference between medians is equal. The null hypothesis that the difference between means is different. Any guess? It's quite easy MCQ. Here
B.
A is the right option because in scientists, null hypothesis states that the difference between medians, that is the standard and the sample median, is zero. MCQ number three. A non-parametric test does not assume anything about the underlying distribution. Following are reasons to run non-parametric tests except for interval scales or ratio scales, for nominal scales or ordinal scales, sample size is too small to run a parametric test. Your data has outliers that cannot be removed. You want to test for the median. Which
D.
one is not the reason to run non? No, A is the right option. Because for interval scales or ratio scales, we use parametric test. MCQ number 4. The sample sign test is based on the direction of the data are recorded as plus and minus signs rather than numerical magnitude. Which of one of the following is parametric equivalent of one sample sign test? One sample t-test, paired sample t-test, independent sample t-test, one sample z-test, two sample z-test. Which is the alternative of one sample sign test in parametric test? Any guess? It is A. A is the right option. MCQ number 5. Based on information from the US Census Bureau, the median age of foreign-born US resident is 36.4 years. A researcher selects a sample of 50 foreign-born US residents in his area and finds that 21 are older than 36.4 years. At alpha 0.05, test the claim that the median age of the resident is at least 36.4 years. Compute the test value for it. Here is the little calculation in which the x we have taken is 21 because 21 were the residents whose age were older than 36.4, and n is the sample size, that is 50. So the value found out is minus 0.99. So the correct option is D. MCQ number 6. The data below are the number of work hours per week of 15 students. At the 0.05 level of significance, test the claim that the median work hour is more than 12 per hour week. Using one sample sign test, the value of test statistic is, this is the data given, and the value of test statistic is 3, 8, 11, 5, 15. To find out this, we will arrange the data in ascending order and we would assign the positive and negative value signs to these values. So here the total values with positive signs are found out to be 11 and the values with negative signs are is 3. So test statistic is the minimum of either positive or negative signs. So here 3 is the minimum. So 3 is the test value. MCQ number 7. The registrar working in medical ward hypothesizes that the median number of patients discharged per week is 40. A random sample of 20 weeks yields the following data for the number of patients discharged per week. State the hypothesis. So, which one of the following is the correct option? A is the right option. because the null hypothesis states that the median is equal to 40, while alternative hypothesis states that it is not equal to 40. MCQ number 8. Sign test can be used for all of the following except to determine the preference for one product over other, conduct a test for the median of a single population, to perform a test for the median of pair difference using the data from two dependent samples, to conduct a test for the median of a single population, mean of a single population. D is the right option. MCQ number 9. The medical officer working in a BHU hypothesizes that the median number of children visiting vaccination center per day is 40. A random sample of 20 days yields the following data for the number of children visiting vaccination center. Test value would be the smaller number of positive and negative signs if sample size is less than or equal to 25, 30, 20, or it is greater than equal to 25 or greater than equal to 30. A is the yes, A is the right option. MCQ number 10. A pharmacy owner hypothesizes that the median number of muscle relaxant he sells per day is 40. A random sample of 20 days yields the following data for the number of muscle relaxants sold each day. The test value is found out to be 3 and critical value is 4. What would you comment on hypothesis? Reject null hypothesis, reject alternate hypothesis, do not reject null hypothesis, reject both hypothesis, or there is not enough evidence to comment. A is the right option since the test value is less than critical value. So the rule of thumb is that if it is less than critical value, then we reject null hypothesis. So this is the key, and thank you. This is the YouTube link for my presentation.
Okay, thank you very much, Dr. Meha. I would listen to the YouTube link and I will give you a very detailed feedback. Thank you very much for presentation today. If anybody has any comment, you are most welcome to please contribute in today's presentation. Okay, thank you very much. Allah Hafiz. See you next time.
Thank you so much. Allah Hafiz.